AI-driven wonderland.
Okay, and we are live today, July 30th. Really excited to have Ian and Ryan with me and Alex here for another installment of AI Office Hours. I'll pass it to Ian and then Ryan to introduce themselves, and then we can dive in. I know you guys have questions. We can also discuss some of the things that have been happening on the news.
Sounds good. Hello, super excited to be here. My name is Ian from TICLE, co-founder and CSO. We are currently building a low-code developer tool where we utilize AI engineer to automatically generate backends for cloud-native applications. And we do so by fetching and integrating domain-specific APIs that we crowdsource and manage through our community. And a little bit more light on the background. For the past year, we actually have been designing a backend as a service system, much in line with the more recent transition into microservice architecture. And as in doing so, we saw clear limitations in being a centralized backend vendor, especially looking into Firebase or Supabase. The APIs that they provide has very limited domain coverage and at the same time very fragmented, which requires a significant time for integrating and using each one of them. So we decided to adopt decentralization to source and maintain high quality labeled code data that we then pass on to our AI engineer to rapidly consume. So again, super excited to be here and looking forward to the discussion. Right?
Sounds good, Ryan.
Hey guys, yeah, I'm really excited to be here as well. I'm the co-founder and CEO of SphereOne. Essentially what we are doing is we're building a one-stop shop for Web3, which is kind of more or less like this orchestration layer, which is powered by a self-improving AI. So effectively, what we have been kind of calling ourselves or coining it is more or less like a Skynet for Web3, which that sounds kind of a little interesting. But the cool thing and kind of some of my background is that I've spent the last 2 years, and our team has spent the last 2 years essentially integrating different protocols in the space. And we kind of ran into this problem where the space is fragmenting faster than what we can actually integrate. So instead of us like building out all the integrations manually, which we were doing at about a click rate of about a chain and a set of protocols every month, we essentially built out a internal tool, which now became the product, which was a multi-agent system, which can create an agent. So we can create essentially or leverage about 30 different agents to create one singular agent, pulling in developer docs, open API specs or contracts, and then kind of create and place that into a ecosystem as a whole to be leveraged kind of by the entire system. So you can have access to everything in Web3 that way.
Awesome. The number of people who are building Skynet is a lot, and I always recommend to not be building Skynet.
Yeah. Definitely.
But yeah, I guess maybe just like to warm us up. I mean, there's been 400B Llama 3 dropped last week, so I'm kind of curious to hear everybody's reactions. You know, if you played with it, kind of how does it compare on what you work on to open source models as well as closed source models? I know we can start with Alex. Let's
I apply. So I run this. Yeah. So one of the North Stars we have is to make models reason well. And an interesting way to approach it is to teach them to solve competitive programming, which is a very self-contained task, which requires a lot of reasoning, and I think is nowhere close to being solved yet. Yeah, I have this little project where people solve them, annotating every step. And I just plugged in 400B. It is not live yet, but I played with it, and it's very effectively, it either solves the problem fully, like no human intervention required. It just, like step, maybe a small mistake, fixes it, fully solves it, submits, it's accepted, or it's clueless. right? So like it just has no idea what to do. No matter how much you nudge it to in the right direction, it just cannot do anything. I'm yet to find something in between. Yeah, so it's but generally, compared to previous models, it's much better. Like the number of problems it can solve is much much higher. And on the last office hours, we had Dima from Fireworks, so we use Fireworks, and it's extremely fast with Fireworks, right? So like the experience of just pressing the button, getting the output is pretty fast. So yeah, like a quick way to test it, to play with it with pretty fast. Yeah, I actually don't know. I just played with TICLE, and it seems to be pretty fast, but I don't know which model it uses and which backend.
So we're testing out a few different models, and for now, actually, we have been pretty busy testing out Claude 3.5 Sonnet, because even though AI code generation is not our main goal, actually, we are more focused in a low-code format, but we still look into it, the code generation part in an everyday basis. And as we have been doing it, we've seen it excel in many different benchmarks. Of course, there has been a little bit of compensations in terms of performance, but we've seen it as a very kind of a positive sign for us to actually try out. And actually at the same time, it really triggered a lot of the discussion internally, because sometimes as we are developing our product, we do consider the ongoing dilemma about is AI tools in terms of the development ecosystem is going to replace developers. And that has been an ongoing discussion within our company as well. And with the new Claude 3.5 Sonnet, it actually triggered a little bit more hype internally.
But if it is to replace developers, that will happen regardless, right? So, yeah.
I mean,
I think we'll take up that topic in a second. Yeah.
Yeah, I mean, on my side, we've tried out numerous different models. So we've done 405B, 70B, 8B. We're predominantly focused in the function calling space. So we've seen really good results from it. We've actually also been, this isn't live yet, but it'll be coming out soon. But we've also done some really cool things around trying to cascade model inference. So essentially leveraging a smarter, larger model for more planning and reasoning tasks, and then use a smaller model that is actually a lot cheaper to run, like a Llama 8B for like an individual agent. So we can have like essentially a series of 30 agents or 10 agents run in parallel, and then have the parent for like the group chat manager essentially be like a 405B or 70B. And we've seen really good results for that as well. And you can run the smaller model locally. So it's kind of like, can we have this world where you have a local model and a cloud-based model or decentralized model?
So with Llama for function call, so Llama is not fine-tuned to be doing function calling, right? Do you fine-tune it yourself, or you like hack it with a prompt?
So 405B we had good results for function calling. 70B is not as good. Grok, if you guys have used Grok, Grok is great, really great TPS, but they have a fine-tuned model for tool use, and we've done some things with that as well. That was pretty good. But we've kind of used just a plethora of different models. We've also tried centralized models. We've had some customers have interesting latency requirements. So we've done centralized models. We've done decentralized models. We're working with numerous partners on that side too. But yeah, I mean, all kinds of cool things for function calling there.
Yeah, I'm curious because I think obviously seeing an open source model, right, that you can customize, that you can fine tune is definitely being something like that's comparable to kind of closed source models. And at the same time, there's this continuous question if the models are kind of the important part, right, or they're just a commodity that you kind of pick up and then you build stuff around, right? And this is kind of being a continuous back and forth, where it's like, is the next model, the next generation or whatever, gonna like replace all of the kind of wrappers and all of the infrastructure we're building around, or you kind of need to manage all that. And indeed, if you're optimizing for like cost and performance, you do need to combine kind of smaller models and use bigger models sparingly. But yeah, just been curious kind of how people reaction have been.
Have you seen, I forget who wrote it, but it was a really interesting take I saw the other day, which effectively was using 405B to kind of like train or fine tune smaller models. So you can kind of use a larger model to actually kind of look at making more or less like an SLM instead of LLM. So you can actually have these like much smaller models which are fine tuned for a particular task, but you could use a more generalized model to actually create that. Have you guys kind of looked at any of that stuff? Because I think that's incredibly exciting.
Well, I mean, the 3.1 is that those
Yeah.
models are fine tuned from the output of the bigger model, and so I think like Karpathy was the one who made the point the most clear to me, at least. It was that, you know, the GPT-2 level model is continuously increasing in quality because we keep training bigger models and then use them to pre-process data for GPT-2. So you can imagine that, and I think like, I mean, I always think, you know, the current pre-training of predicting next token is, let's say, rudimentary, or we use a suboptimal word, right? It's like, it's the easiest thing to do. It's the easiest loss function to use because that's what we have. But you can imagine actually if we had a data set that you can train, you know, pure reasoning, question answering, you know, information retrieval, all these tasks, code generation, you can train way smaller model to be able to do all that, right? You just need a data set like that. And like that data set doesn't exist. But if you have a bigger model that is like starting to be pretty good, you can actually generate a data set and then train a GPT-2 low model on that. So, I mean, I think the most unclear part is like this new set of capabilities that appear, right, with this different sizes, which, like as Alex described, right, it's like it's either it is able to do it even if it takes like multiple tries, or it's just purely not able to do it at all, right? And the part that to me, and I don't think anybody has described very well, kind of this boundary, like where that boundary comes from. Is it literally like it hasn't seen that example enough in data, or it's just not able to, you know, compute over it? Like what is this boundaries that kind of we see in this ability to reason, and kind of when it's not able to grasp it, even literally like if you prompt it with, you know, correct direction, it's still not able to go from it.
It's worth mentioning my sample size was pretty small. It was like 6-7 problems, right? So I actually suspect that there's a frontier. It's just relatively small, right? Like if you imagine like plotting, doesn't have to be competitive programming, right? Like you take any domain where models can solve, like, you know, a subset of it and completely clueless on another. Like naturally, if the domain is large enough, then you do expect that the frontier is going to be a relatively small percentage of the current of the total set, right? Because just because the number, how do I explain it? Just because, like, you know, the difference between the easiest and the hardest is so large that you know, like any you know, like small window will only capture a small subset. Yeah, and I think an interesting evidence, something I discussed with Bowen from NEAR.AI a couple of days ago, is that if you think about the DeepMind's paper on IMO, I don't know if we plan to talk about it later today.
We can shift into that, yeah. Maybe describe it for those who are not reading all the papers that have been published by DeepMind.
Yeah. So I guess it would be pretty hard to live in the modern world and not hear the news that DeepMind got the silver on IMO, with a couple of asterisks going both ways. One asterisk is that they were 1 point short of gold, so it's almost gold. And moreover, they didn't solve at all the last two problems. And interestingly, on IMO, when you're in that state and you're a human, what you would do is you would write anything, any thoughts you have, because that could be worth 1 point, right? And DeepMind could have done that. And like there's a belief among some people in the community that they didn't do that just not to water down the result, right? Like it would be worse if they said, hey, we have gold, and people would be like, yeah, but like that 1 point is bullshitting, right? So, but the second asterisk is that it took them 3 days and the actual participants only had 4 hours, right? But I think that is completely irrelevant. Like, if there's one thing we're good at as a species, it's optimizing something that takes 3 days to take 5 seconds, right? And the way they did it is, so let's put aside alpha geometry for now. So alpha geometry is an older tool. They've had it for more than a year, and it solved one problem. But the remaining 3, they solved by converting the problem statement into lean. That is still done by a human. They have a model that kind of can do it, but it can hallucinate. And if if you make a mistake in the translation, then all bets are off. So that is still done by a human. There's a human who converts the written statement into lean, and then they do effectively give or take alpha 0 on lean. So they train using something, some sort of reinforcement learning with tree search, and then they do inference using tree search until they find the proof. And the beauty of lean is that if you have the statement, if you have proven it, right? So unlike human written proofs that are very hard to read, and lean proof is there's a system that checks it and it knows if it's correct. And so for 3 problems they found proofs, and those seem to be relatively hard problems. So it's not a small achievement, right? And something, coming back to my conversation with Bowen, something he mentioned that it's interesting that like the way they train, right? The number of lean programs in the world is very small, right? Lean is a relatively young language, and it's a very hard language, right? So the number of people who write in lean is relatively small, and so if you train on all the lean available, you're not going to go far, right? You need to be synthesizing it, and the way they synthesize it is by they get that step. I don't know fully where they get a lot of problems, but they get a lot of problems without proofs, right? And then the system proves them, and when it's proven, it goes to the data set, right? And so what is interesting here is that initially, of course, the system is relatively weak, so it can only prove the simplest problems, right? And so it proves a lot of simple problems. It gets better at them, and you would imagine, right, that there are 2 possibilities here, right? We live in one of the 2 universes. In one universe, it will eventually become very, very good at solving very simple problems, but it will never transition to solving anything harder, right? So it will get stuck. And in another universe, it keeps on getting better, and like once it gets better, it solves more problems. It gets better, solves more problems, and eventually there's like this continuous transition until it gets to hard problems, right? And it seems like we live in the latter universe because they did eventually get to solving AMO. So that is something that was not necessarily the key, like it wouldn't be obvious that that's the case, but it seems to be. So that's pretty interesting.
Yeah, and it actually triggers a different question that from a business perspective, you mentioned 2 different kind of future that we can expect from this, and actually it getting better and better at solving more problems. And later on, maybe the other side would be doing different, solving different smaller problems and only staying at that level. And you would have to find a different method to actually find solutions for solving more complex questions. And from a business standpoint, from an economic standpoint, what would be a little bit more, what should I say, a little bit more closer to what the projects can actually adopt at the current moment, and what would be more cost effective for us to actually expect and adopt?
Yeah, so I think from this perspective, one thing that I still mostly agree with is that like if you embark on a journey of building something that will be ready in a year, you should effectively, be building assuming that the models will be noticeably better, right? So it's like if you try to build something that can be built with existing models, then you will be a little bit behind, when it's ready. But I think another interesting thought, which is, so this, like with everything DeepMind does, it's extremely mind-blowing, and it's very hard to generalize to the wider set of applications, right? Because okay, we see that in this particular application of proving, Olympiad level mathematics. It's very good, but it's very hard to understand if that will generalize to wider applications of Lean, right? Because it wasn't trained on like it wasn't trained on practical applications, on practical problems, right? It was synthesized problems. And it happened that in this particular case, synthesized problems helped to solve Olympiad mathematics, right? And so we have no idea whether similar synthesized problems will help you apply Lean in other domains, right? Because Lean is or like generally. So I think first of all, Lean is positioned today to be the de facto standard language of formal proofs of tomorrow, right? Because all the research happens in Lean. The standard library is getting bigger and bigger. So I think effectively Lean is becoming a synonym of formal proving, right? And if it gets extremely good, go ahead.
To interject here, the formal proving is needed for actually programming, like the AI software engineering. That's like a foundational piece. Otherwise,
so it's
you can
not
have code.
Yeah. So necessary is a strong word, right? Because we've been building code for decades now, and I would say throughout those decades it was also necessary, but we somehow managed to get by without it. And the worst that has happened yet is a complete collapse of the whole world for one day,
for a couple of days.
Yeah.
But like you can imagine that on steroids when you also have AI that is like of a level that can break any code and inspect it while inspecting it, or
yes, exactly.
Given the side effects of it.
Yeah, so I think so one thing is that we are probably getting to the state where AI will start breaking code very well. So at that point, having code which is formally proven would be a massive asset, right? So like it's not going to be broken, right? No matter how smart your AI is, the code is proven to be doing exactly what you want. So at worst, you can still mess up the actual guarantees, right? So you have proven that the code does that, but that is messed up, right? It's not what you actually want. But the second thing is that, generally, everything we use today, all the websites, all the apps, they're all garbage, right? It's just like you open the United app and in the airport, and it like crashes on you, or like it doesn't load stuff, or like, and that's like throughout all the like banking apps, Notion, they all, right? And we start like. If we were to generalize that segment of DeepMind, we might be moving into the phase of humanity where all the code will be formally proven because like AI is getting good at doing it for us, right? So that would be pretty cool, and like that would be actually an interesting thing, like for a startup to say, hey, let's say it is the case. It might not be the case, and then my startup will die, but there are 99 other reasons it could die. Right, but let's say it is the case. Let me bet fully on Lean being fully synthesizable in a year, right? Like, can we do something cool, to be ahead of the curve, where all the code is formally verified and it doesn't get hacked, it doesn't fail.
Yeah, so maybe like Ian, because you brought it up, right? Like with Claude and with others. Hey, the code generation is getting, to a level where like it give you a dirty prototype pretty quickly, right? It may still have some issues, or it's not handling some edge cases, and it's harder to integrate in a bigger code bases usually. But you can see like, hey, if it's a single file thing, like it can, start getting there, at least like to start. But indeed, the question is the complexity of integrating kind of a single module into a bigger system is where lots of complexity is. Like for a person to write a new program, it's pretty easy, right? Like, but actually adding code to existing code base is where complexity is, because there's so many different conditions and variants, and usually some other things that like only in few people's brains potentially that you need to recover from reading this code base. And so I think the kind of looking forward, we will need some combination of these tools to come together to be really both advancing ability to like expand code bases, right, with guarantees that it's not going to fail again when somebody pushes like one line change, and at the same time, this also would allow to have kind of more complex transformations to the code base in itself, right? Because semantically, you can imagine like I'm looking at some application, I'm like, okay, I want to switch database from SQL to NoSQL, for example. Like that's a very simple semantic change, which requires a lot of syntactic like re-implementation of in the code base. But like for that, you need a lot of like guarantees and understanding of what are the differences between SQL and NoSQL and how those are being then kind of surfaced in the application in the backend, for example, because of the complexity of the retrieval, et cetera, right? So all of that is like models have some of that information just because they statistically saw a bunch of those cases, but like making it a lot more apparent, right, by maintaining some of the, let's say, lean proof around it would allow to actually have like a pretty good advancement. I mean, that's kind of what we've been, with Alex discussing and working on some of the pieces of that. But I mean, we do think it's coming, right? Although we've been thinking about it that it's coming from 2017, that it's near.
And before.
And before that, it was less near before that, but yeah.
I mean, I well know that you guys started off trying to develop AI developers, so you guys have an extensive background in this. And for us, actually, what we're more focused in here is that we want to create an actual use case, because it feels like we are at a critical stage where Web3 has to prove itself that it can have an important role to play in the AI game. And for us, how we saw it differently is not from the AI code generation perspective, but actually putting it in a low-code format. So it is a lot easier for us to compose it. And for the people, as you mentioned, like when they have to go back and switch out something, it's a lot easier because it is simplified into smaller blocks that they have pulled through our AI engineer. And for us, of course, we can't compete against these bigger models or big tech companies that are working on these technologies, especially like IBM just recently open sourcing their Granite family, and they're trying to receive a lot of feedback and community support from developers as well. And for us, we are trying to do the same thing, but we want it to be in a predefined and a pre-built package as an API, which actually gives us a little bit more flexibility. Of course, we won't be able to build super complex apps at the moment, but the more we actually build out this code base and build out this API registry, we will be able to tailor and cater to more of the custom and unique business needs that the Web2 application builders actually have. And from here on, I believe we can actually generate those use cases, and based off of that, we can actually try to mimic what these bigger models are doing. And I don't necessarily believe that we have to work against these bigger technological innovations, but somehow if we can work alongside of it, then it would be a better option for us. Of course, decentralization has a lot of value propositions, and we do believe in it. But for us, we're just starting off from the data layer, which is the bottom layer of the AI stack. And everything else, of course, we have it in a traditional setting. The only difference is that we have it all open and publicly available. So from there on, we're trying to see where this can head in building more complex softwares.
So for the, I think one interesting question here is, if I understand correctly, the sort of mental model of how a person would build a, I don't know if you call them TICLEs. If a person builds a TICLE, that there's like I imagine, like the end goal is that there's this massive inventory of APIs, right? And so I go there, and it's not just that I'm relying on an AI to build a whole system from scratch correctly. I'm relying that it's writing a small, effectively glue code correctly, which is a much smaller scope, plugging in into all those APIs, right? And like when I was playing, I see that APIs have a reputation. Like reputation 10 means that don't touch it. Reputation 90 means that it's probably legit, right? So in this model, The problem I see, and I'm curious how you guys think about addressing it, is that APIs go down, right? And so if we build a whole ecosystem of things that are like interconnected, right? And like imagine this completely made up example that many people need an API to pad a string with spaces to the left. Let's call it left pad, right? And then the left pad API goes down, right? What happens? Like how do you think about the problem of APIs disappearing or like introducing breaking changes and the cascading effect of?
So as you mentioned, the API is, of course, one of the APIs that can actually go down. But what our AI engineer is good at is that it fetches and integrates it. As Ilya mentioned, of course, it's not just the code writing side, but it's also the knowledge and the expertise that you need from the backend side. And from there on, we actually have optimized the Kubernetes cluster and allocating resources in an optimal way. So whenever one goes down, of course, at the moment, there could be a little bit of delay in terms of how the app will run. But at the same time, we'll have a group of developers that are working on and monitoring the specific API. So we'll try to push different version updates through it. Of course, even proprietary APIs that are provided by low-code solutions that already exist in the Web2 ecosystem, they are not perfect, and plus on top of that, they are not verifiable. So when the users actually receive the APIs, they don't know if that's the best quality that they can receive from the market. So at least what we can offer is that we actually create this merit-based ecosystem because it needs to be searched and selected by the AI engineer. So at least what we know is that the code itself is as secure and as high code quality as possible. If it goes down, of course, thereon, it is based on us, and it's based on us being able to quickly ship those problems and outsource those problems to our developer community.
I see, but I think you implicitly answered the other question I asked, which is that, like, in fact, for as long as the API is deployed via TICLE, effectively, there is no way. Like, my bigger question was not just the server going down, but the developer, like the original developer, just completely shutting it down. But I guess as long as you own the APIs, you can just, like, I guess you can forbid developers shutting them down, right? It's
right. So we call user-owned APIs. So basically, if the user decides to just completely ditch the API, then of course we will be able to find a follow-up API that we can quickly replace with it.
Yeah.
So I think it's the same with any kind of user-owned assets. Of course, if there are slashing rules and so on, there will be less people who actually ditch whatever asset they're putting out in the marketplace and actually providing people to pay for it. But at the same time, for us, we are currently not trying to impose any kind of slashing at this point. We just wanted to make it a little bit more collaborative rather than being penalty driven. So for us, when that happens, we'll be able to replace it with some other APIs within the same domain and within the same domain-specific functionalities.
And there's one more thing, which is, I'm pretty sure it's on your roadmap, but I didn't see it there. But of course, when I deploy my API, I want a little bit of money streaming to my account every time it is called.
Right. So I guess if you're a supplier of the API, so we basically try to incentivize in a very different way. So the first one will be the hit rate, which basically means how much recommendation it actually receives and how many times it actually been recommended to the end users. And the second is actually based on the usage. So as we started off as a backend as a service, we still try to position us in that way. So people will pay monthly usage fees based on the time that they have instantiated the API stack. And based on that, we will minus all the infrastructure costs and so on. And from whatever's left, based on the usage percentage, we'll be able to distribute it to the API providers. So of course, we could ship out tokens as incentives, but we don't see it as a sustainable way to do it. Of course, in the beginning, we'll have different code recruiting events for different domains, and there will be different incentives that people can take off from. But the main sustainable income for the API providers will be based on the actual usage.
Yep.
Maybe a similar question to Ryan around agents, right? Pretty much, how do you manage agents lifetime and payment, and if like people are able to spun up own agents, if the agents kind of may disappear,
Yeah, absolutely. So on our side, we explored that space quite a bit originally for allowing people to create their own agents to then like support a given protocol if they would like to. So maybe like someone wants to create a Uniswap agent or a wormhole agent, whatever it may be. Um, what we kind of ran into and what we kind of done is we shifted some things around in our roadmap for that because we ultimately, because we're dealing with money, a concern kind of popped up around like how do you keep a nefarious person out? So how do you essentially say and enable a way in which like a nefarious person says, okay, if I'm doing a swap, I'll do the swap normally. If it's less than $1 million, if it's more than $1 million, then I'm just going to take the money and run. So, you know, you can have reputation systems, and what we were looking at is like, there's reputation systems you can have. You can then effectively game those for what we're doing. If you had slashing stuff, that was something that we kind of looked at. There's just some kind of concerns that we had around that. So what we have actually done is like we built out and we turned our tool loose on our community, and we wrapped over 3/4 of DeFi in 3 days. So we ended up doing like 800 different agents quite quickly. So that was really cool to see. But the problem arises where is that if that code touches someone individually, then how are you ensuring that they don't have a particular like nefarious piece in there? And we may do slashing or whatever, but if it effectively has a problem before that, then I think there's a larger issue. So what we've been focusing on more now is that effectively we can build out a series of agents ourselves using this tool that's like more self-replicating. And then we can actually do more community-owned AI. So effectively implement something. There's an experimental paper that came out called co-learning, but effectively it's where each individual use can be ran, and we can identify. We have a knowledge graph that associates between all the different agents, so you know how to traverse and which agent to populate in an event that you're trying to do a given transaction. So we can incorporate those directly, and then if there's a problem in the overall like flow of that individual agent. So maybe it gets transaction first before getting a quote. We can then refine that, and through that refinement, that person can be rewarded, and then the next person has a better experience the next time. And then what we want to get to is where users own the agents, but we want to have more or less more functionality of using the existing library that we effectively can build out ourselves, and then enable people to extend capabilities on top. So maybe they want to do great payments on like an Akash or something. We could then say, okay, you can use these series of agents up front, and then you're effectively composing this into a button. So you don't have to actually type out or do anything directly. It's all like kind of like through a button interface directly. And we can have more and more of these buttons or different capabilities be used, kind of what we did recently with TIPLink.
So you mentioned you get created. Oh, go ahead, Illia.
No, go.
Yeah, you mentioned you created 800 agents in several days. So this is because agents themselves are written by an agent, right? Or you actually have humans write 800 agents.
So what they did was we had a tool that was deployed in which you could say, I would like to create an agent for Uniswap. And then what we can do is we could pull in the contracts of Uniswap and the developer docs. We create a RAG agent for like a micro view over what that agent actually does and what Uniswap is. And then what we're doing is we're not creating like a whole generation piece. We're more or less like stubbing out the functions associated with that protocol. And then we're just saying, okay, the agents essentially will interface with those stubbed out functions. It's like getting a quote or getting a transaction. So we're not like replacing their contracts. We're just kind of creating a interface layer on top of that.
Yeah. And so what is the what is the end goal of an agent, right? So like, let's say I have an agent for Compound. Well, let's not do for Compound. Let's do for Avi.
For Compound, it's going to be attacking the governance.
Yeah. So go for it.
So the question is, what is the utility of the agent? So first of all, is the agent designed to be used by another agent or by a human? If by a human, what is the, like I'm a human, right? What is the use case for me to use the agent?
The agent itself can be built by other agents, and then the user of it can be other agents, or it can be a user directly. So we're on Kinetics, the #1 DEX on Kava chain. We're deployed on there. We deployed 5 agents there directly. And essentially what you can do there is you can ask it and say like, what is kinetics, who built it, stuff like that, hit the RAG agent. And then if you wanted to like add in something where it's like, I would like to do a swap and then tie it into a 100x long position through their perps product, you can essentially combine the two together and create one seamless stream. So then it's more about like partnering with like you guys and other people to essentially provide a chain abstracted experience. So then you populate all the transactions forward, and then how do they go about signing that? And that's really up to the user. Do they want to go one by one? Do they want to sign like via a policy engine? Do they want something that's chain abstracted? That kind of thing.
So is it more about like making more user-friendly experiences, or is it more about like abstracting away the boundaries of applications?
Yeah. So what we found when we were doing payments was that it just was incredibly difficult to like try and support everything and everyone. Someone would have money on like Kava chain, and we don't support Kava chain. So then all of a sudden, how do we add in a bridge from Kava chain over into Solana or NEAR or whatever? And it's like what we ended up doing was we incorporated over 130 different pieces of infrastructure. So we built out a lot of stuff to support 18 chains. And it was just like, this is like a never ending problem. It's like the protocols just kept expanding faster and faster. There's more chains. Now you have L2s and L3s and all this stuff. So part of it is to create a user-friendly experience, but it's also to extend the capabilities of that actual like protocol directly. So instead of that protocol having to figure out how do I bring in an on-ramp, how do I bring in a bridge to get people's liquidity into my like actual project, we can say, hey, use our like effectively our library of agents, and then enable your users to pull in funds easily through this kind of like one-stop shop kind of system, and then they don't have to spend the time to do that.
So I actually I'm interested to like challenge everybody's perspective on what is the difference between an agent and an API.
For me, what we've seen is that when we did payments, we had a lot of issues with redundancies and RPCs going down. And so it's kind of more or less what we continue to see is like there's increased redundancy and fault tolerance. So like at least how I'm looking at it, and I'm biased, I think it's like the next step almost, because I feel like the unlocks we have had enable a lot more of a like say I want to hit like a particular RPC, I just want to get my balance, or I just want to understand like what this wallet is or whatever. I just want to do a transaction. RPC goes down, we can have an agent then populate a new RPC, try it again. But instead of it being like written out manually in code, and that would have taken a developer maybe a week to implement or go through the whole process, we can have effectively something with some reasoning capability to provide this fault tolerance in association with what the user is trying to do directly, which I think is kind of much more extensible and flexible. So that's what I get excited about between the two.
I mean, from our perspective, it's quite similar as well, but what APIs actually do is it actually can only serve a specific function, and it can actually only take in do certain actions based on certain signals. And for the agents, where we see it in the future is that they can actually be interoperable and they can actually be working together autonomously. And from there on, of course, we can make it to be a bit more fault-proof. And at the same time, just providing it as a single, like more than just providing it as a single API, it will have a little more flexibility in terms of actual business applications.
Yeah, I think for me, the difference is in like semantic versus syntactic, right? The API is a syntactic act, like syntactically defined action, and kind of fault tolerance, as well as some intelligent understanding of arguments. All of this is more of a semantic. Like I want the result. Like I don't care which RPC you use, just figure it out. But at the same time, you can imagine APIs becoming like, OpenAI API is literally a semantic thing, or you're calling an agent API. And so I am kind of curious where that line lies and how much more semantic can APIs become broadly as well.
I want to bring up another thing. We mentioned it a couple of hours ago. There's this website called websim.ai. which if someone who watches it didn't see it yet, it's completely mind-blowing, even in the modern age of AI. WebSim, like websimulation.ai, websim.ai. And a couple days ago, maybe earlier than that, someone reverse engineered it, right? So they found how it works. It uses Claude, which I guess is not very surprising. And a very interesting aspect of it, which is very relevant to Ilya's question, is that effectively they ask Claude to write the website based on your like small prompt, on the fly. But that website might have Ajax queries, right, to the backend, but there's no backend, right? So the way they do backend is that whenever there is any Ajax query, they go to Claude and say, "Hey, Claude, we have this Ajax query for this website. What should we respond with?" And Claude is, on the backend is coming up with a response. And like if you play with websim.ai, you will see that like it works, 99 times out of 100, right? So here, like that's an agent for sure. That's also an API.
Yeah, I think somebody did as well an example where the backend is just LLM responding to like
exactly right. But here it is plugged into an actual website, which is built on the fly, and it all works seamlessly, right? So like especially you can intentionally come up with examples that will have an API, right? Like you can have it as part of your prompt saying, "Hey, it like calls to an API to do something," and it all works very well. It's also a cool thing, when you prototype a website, before you have the backend, you can
just stab it with LLM.
Yeah. Later you can probably you probably want to replace it with an actual backend, but for the early testing, it's a nice if it does something weird, you just reboot it. But that is actually not like a new tool that exists in the tool chain of the developers.
And you can imagine
universal API.
The LLM that has memory, that has ability to like use a bunch of tools, then potentially with like optimizing its you have a router in the beginning that if I have already a function like this called a function instead of unrolling chain of thought and figuring out, and if not, unroll chain of thought and write a function so that next time you can call it, right? And so you kind of cache, like while you're doing it, you also cache everything, and then you have some database access, let's say. So like it will just build the backend under the hood while you're actually doing this.
Yeah, I think I'll go for you.
I mean, it truly is kind of a crazy world that we are jumping into, but at the same time, of course, these are newer technologies and newer kind of like tryouts with the existing solutions to kind of find ways to make it a little bit more fun and actually just find loopholes into it. But at the same time, for actual use cases and enterprise adoptions, when it comes to agents and APIs, it really depends on how much they can actually rely on it and how much they can actually securely adopt it from an enterprise standpoint. And from there on, I think, of course, where we draw the line between the two is actually important. But at the same time, just working within the traditional setting and actually trying to provide what they actually need at the moment is also a critical issue that we have right now. So, of course, drawing the line, we would at some time we will have to draw the line between the two. But for now, I think we can just work with what we have and actually try to innovate on the usability, which is quite similar to what Ryan is trying to achieve with the project as well.
The thing I get excited about is I think Andre Karpathy wrote like a tweet or something like that about like LLM OS. So he kind of talked about this kind of concept or idea as well. And I think that's like, I mean, he's had some very interesting thoughts on like software 1.0, 2.0, and this LLM OS. I've been kind of following some of that. I think that is really an interesting thought or perspective on maybe where software can go, and maybe what the future might hold. But yeah, I mean, I think it's just exciting times ahead with the existing tools that are available today. And even inside of that, it's like, there's lots of really great research out there. I mean, really good products that are like multi-agents type systems like Crew AI and AutoGen they've done some things around like I think one was called like agent optimizer. So effectively, if you build out a given system, you could then find out a predefined path to do like something in the future. So if you do like spin up the backend on the fly, in this case, you can actually like replay that later. So it's almost like you store that in like memory, and then you like can cache that and then replay back that same system for the a similar like intent or like whatever you're trying to do with that overall like website, which I think is awesome.
And the post about software 2.0 is from November 11th, 2017.
Yeah.
So it was,
which is just wild. I mean, I think I got into AI in 2017, definitely not nearly as much as you guys. That's how I actually got into Bitcoin or crypto, was I built out an AI trading bot. And then I started a little NLP company that I did for automatically applying people for jobs using like an algorithm I built out. But I mean, even back then I thought, okay, AI is going to take over the world like today, like it's happening today, like it's it's over. And then the LLM space though, like when it first came out, honestly, I wasn't as excited. Like I was like, okay, this is very cool, very interesting, but I wasn't as excited as I probably should have been. And it really wasn't until like some of these more recent adaptations that I found to be quite interesting. So more or less like how you add and incorporate things into it. Maybe Monte Carlo like tree searches for reasoning on top of it. It's like the DeepMind is doing great work on that. I mean, that's what I think is what gets me really excited about what is yet to come, kind of thing.
Yeah, I think that's generally. Well, when was it? I think it was like half a year ago when Illia drew this diagram, which I think is the core of how the systems ideally should operate, where the user communicates with the agent, and the only goal of the agent is to create a symbolic representation of what the user wants, not the solution yet, just rephrasing what the user wants in a symbolic space, and then it communicates it back using not an LLM but a deterministic, like symbolic to natural language conversion, right? So it tells to the user, hey, this is what I think you want, translated from my language to your language in a deterministic fashion. Does it sound right? And then when the user says yes, then we do synthesis in a symbolic space, guided by the model, right? What DeepMind does, what presumably Strawberry is, and then when it is synthesized, we know that it is correct for as long as the user did properly confirm our understanding, right? So that's then the API that is synthesized is correct, and then I actually think that this is in the world with a lot of APIs, which I believe myself in, or like big global namespaces. That's very important, right? Because if you have 10,000 APIs built by different people, you definitely want to be sure that they're actually doing what you want, and not doing it 9 times out of 10. So that's the exciting. I think that's how it should be going forward.
I mean, verifying that each of these APIs do exactly what the user intends to do is very important, and completely agree with it without a doubt. Also, spinning off of that is that as you guys open the agent marketplace, most of those, of course, as you talked about, there are newer technologies and tryouts, but most of those agents will be connected to certain different APIs. And for that marketplace to work seamlessly as a platform, wouldn't you need a protocol to actually integrate those APIs seamlessly within your marketplace as well when the user actually picks it up from there? And curious to see if you guys have any thoughts on how the users will pick up those agents and try to adopt them within our ecosystem.
Well,
Yeah, I think I
was asking this question because I actually think we'll just be living in this API to agent spectrum, right? API to like full LLM spectrum, right? Where agents in a way are just constrained LLMs, which expect some type of input or can work with some kind of input. Themselves can use a bunch of APIs or other agents, right? And then you expect the output in a certain format, right? Which again, APIs are kind of that, just like you don't expect them to be as non-deterministic as agents right now, but then agents are more intelligent to result, right? But it is a spectrum, and so you kind of want actually agents to become more like APIs, where they're predictably going to deliver the results. They're not going to fail. They're not going to go in like on a side quest of building something that you didn't ask them to do, right? And so I think like, how do we make agents more like APIs? That's kind of the mindset in a way I wanted to kind of challenge as well, because I think it will be important to understand, liveness of this agent's ability to perform the tasks. How do we benchmark them? And so similar to APIs, you want to know all of this information, how to use them, examples, etc. And so, yeah, to me, that's kind of a spectrum that is probably going to end up in one place, like eventually, right, where all of these pieces kind of just come together. Ryan, you wanted to say something?
Oh yeah. I was just going to say, I totally agree. I think that, APIs in general, definitely extremely useful into the future. And I think like more or less like the agents and how I think about it as well is like, it's almost like the glue that kind of sticks it together, but you want it to be deterministic, somewhat in its output, and reliable, that it does work. And I think for us, like what we have seen really good results from is just adding like a knowledge graph associated with it. So then that's like more or less like helping the traversal of like different agents, and then incorporating those into a singular conversation, which then talk to and communicate to multiple different APIs or contracts. I think that like those types of like supporting pieces of infrastructure around that system is like very helpful as far as like what will probably come next. And then probably being able to like traverse like and ideate between different possibilities is also helpful. Like for us, like kind of the end state where we're going to is something like every Wednesday rebalance my portfolio for the best yield. Then we can traverse across the knowledge graph, say, okay, Superform, Ichi, and something else come in mind for maybe Morpho for good yield protocols. We can say, hey, here's the 3 results. Which ones do you like? And then they say, oh, okay, I want to go with Superform on, Arbitrum or something like that. It's like, okay, you kind of tap that. And then we're able to like more or less traverse and incorporate and bring that in. But the agent is like the spectrum of what they're actually looking at and doing and reasoning becomes extremely, extremely narrow. And we're more or less like, I always think about it as like we're almost trying to supply employees with a lot of different bits of information in which they can be successful. So I think that's a lot better of a end result versus like just saying, hey, 1, 2, 3, go. Then they're just trying to like identify, what do I do? I have 50 options. Which one do I grab? And then trying to just pick and choose kind of thing. So yeah.
Yeah.
Alex,
Okay. No, I was saying we're like 1.5 minutes away from the end. I don't know if we have any final interesting thoughts. I don't.
Well, I think to wrap it up, maybe I'm curious, kind of just in a couple of sentences from you, Ian and Ryan. How do you see, let's say, like your product is fully rolled out, people are using it. What would be the most like impactful change, right, for the user? Like, what is the 10x better experience that they cannot get right now?
I'll go first. Actually, as you may have noticed from our project, is that we actually create a lot of demand from the Web 2 side and actually try to solve what Web 2 has been really thinking about for the past few years, which is to really democratize the development. So from our end, providing a conversational panel and actually being able to just plan, build, and ship out your backend just within a few seconds, and actually be able to just deploy it and instantiate it with just a click of a button, I believe is like an end-to-end automation that they haven't really seen in the past. And at the same time, it really brings a lot of freedom and democratization to not just less seasoned developers, but at the same time, non-technical users as well. So from there on, we're actually excited to see how users actually use our product and how it kind of fosters a little bit more collaboration within that company.
Yeah, and then on my side, really what we're trying to do from a very high level is just provide like a Visa-like experience to the masses for Web3. So like, I don't think that you should have to know about the given blockchain or even the protocol that you're necessarily implementing or working with in order for a user to actually use the space. I think like our old saying when we first started the company was we're building crypto for grandmas. And I think we've always been kind of true to that ideal, which is we're just trying to make this really usable for the masses where people can actually go in and if they want a 50% yield on some kind of like LP position on a DEX, they can do that, but they don't have to understand, how do I on-ramp, bring this money in? What's Arbitrum versus optimism versus, whatever. Like that just seems kind of ridiculous to me a little bit sometimes. It's very cool from a technical side, but I think from a user side, that has always been a huge problem, I think, for the industry. So from a high level, what I would want to do is just provide the Visa-like experience to the user where they don't even have to really think about it. It's like a one-click or a swipe type system.
Yeah, we call it chain abstraction for Web3 people. For Web2 people, we just don't call it. They just should use it and not know about it. So yeah,
exactly.
Great to have you both here. Hope it was engaging, entertaining episode for everyone. We'll see you next week and have a good week.
Thanks for